The night sky has always been a mirror, reflecting our deepest questions back at us. For thousands of years, we looked up with nothing but our own eyes, seeing the stars as fixed points of light, frozen in a silent, eternal dance. We believed the heavens were unchanging, a static backdrop to the brief and busy lives of humanity. But as our tools grew more refined, we began to realize that the silence of the night is not the silence of stillness. It is the silence of a deep, profound motion, a choreography so vast and so slow that it escapes the perception of a single lifetime. Recently, our finest window into this motion has been the James Webb Space Telescope. It sits nearly 1 million miles away from Earth, at a quiet place in space called the second Lagrange point. There, balanced between the gravitational pulls of the Earth and the Sun, it hangs in a perpetual shadow, protected by a sunshield the size of a tennis court. It is cold, colder than any place naturally occurring on our planet, and in that deep chill, it can see what was previously invisible. It sees the heat of the first stars. It sees the chemical whispers of distant atmospheres. And most recently, it has seen something that challenges our understanding of the neighborhood we call home. James Webb has detected something moving, not a planet orbiting a nearby star, nor a comet tumbling through our own solar system. This motion is occurring far beyond the silvered edges of the Milky Way, in the profound emptiness that lies between galaxies. It is a detection that reminds us that the universe is not just a collection of objects, but a fluid, living system of currents and tides. To understand what this movement means, we must first understand the scale of the stage upon which it is appearing. Our galaxy, the Milky Way, is a sprawling city of stars, a disk of light 100,000 light-years across. It feels like an island, self-contained and isolated. But the space outside our galaxy, the intergalactic medium, is not truly empty. It is a thin, ghostly sea of hydrogen gas and dark matter, a realm where the laws of physics play out on scales that dwarf our imagination. When we say something is moving outside our galaxy, we are speaking of the true frontier. We are speaking of the space between the islands, the vast oceanic stretches of the cosmos where the rules of motion are governed by the invisible hand of gravity and the mysterious expansion of space itself. The detection made by the James Webb Space Telescope is subtle. It is not a sudden flash or a dramatic streak across the sky. Instead, it is a shift in data, a tiny variation in the infrared spectrum that tells a story of momentum. It is a signal of something with mass, something with intent, navigating the void. It forces us to ask what could be large enough to be seen across such a distance, and what forces are pushing it through the darkness. As we settle into this exploration, let us leave behind the noise of our world. Let us imagine the telescope, its golden hexagonal mirrors polished to a perfection that allows it to capture photons that have been traveling for billions of years. These particles of light are like messengers from the past, carrying news of events that occurred long before the Earth was formed. By catching these messengers, Webb allows us to look not just across space, but across time. And in the data it has sent back, we find evidence of a cosmic traveler, a presence moving through the extragalactic night, inviting us to reconsider the boundaries of our celestial home. The motion detected is a reminder of our own fragility. We are passengers on a small blue planet circling a modest star, located in a quiet arm of a typical spiral galaxy. We often feel central to the story of the universe, but the vastness outside our galaxy tells a different tale. It tells of a universe that is mostly empty, mostly dark, and mostly indifferent to our presence. Yet, the fact that we can detect this movement, that we have built a machine capable of sensing a whisper in the void, is a testament to the human spirit's need to know, to see, and to understand the context of our existence. The intergalactic medium, or the IGM, is perhaps the most mysterious landscape in all of science. It is the connective tissue of the universe. If galaxies are the organs of the cosmic body, the IGM is the blood and the breath. For a long time, we thought it was a total vacuum, a place where nothing happened. But Webb is showing us that this void is active. It is filled with filaments of gas that glow with a faint infrared heat. It is a web, a cosmic web that links galaxy to galaxy. And now something is moving through those threads. As we breathe in the quiet of this realization, we begin to see the universe as a more dynamic place than we ever dared to dream. The stars are not just lights in a dome, they are part of a grand, flowing river. And somewhere out there beyond the reach of our own sun's gravity, a new chapter of discovery is being written in the motion of a distant shadow. To understand the significance of a detection outside our galaxy, we must first map the territory of the great outside. We often speak of space as being empty, but emptiness is a relative term. Within the Milky Way, space is filled with the dust of dead stars, the radiation of living ones, and the magnetic fields that guide the flow of plasma. But once you cross the outer reaches of our galaxy's halo, a region of sparse stars and hot gas that acts as a buffer, you enter a different kind of space. This is the intergalactic void. Here, the density of matter is so low that a single atom of hydrogen might be the only inhabitant of a cubic meter of space. It is a vacuum more perfect than any we can create on Earth. Yet, this nothingness is the primary constituent of the universe. Galaxies like ours are merely the bright froth on the surface of a deep, dark ocean. This ocean is the setting for the motion Webb has observed. The scale of this geography is difficult for the human mind to grasp. If you were to leave the Milky Way and travel toward our nearest large neighbor, the Andromeda Galaxy, you would have to cross 2.5 million light-years of this void. A light-year is the distance light travels in a year, about 6 trillion miles. To cross that gap at the speed of the fastest spacecraft ever built would take tens of billions of years. It is a distance that effectively isolates us. And yet, the gravity of these two giants, the Milky Way and Andromeda, reaches out across that gap, pulling them toward each other in a slow-motion collision that will take billions of years to complete. But the motion detected by James Webb is not just the expected drift of galaxies. It is something more specific, something that appears to be independent of the large-scale flow of the local group. To find something moving in this context implies a velocity or a trajectory that stands out against the background of the expansion of the universe. As the universe grows, space itself stretches. This expansion, discovered by Edwin Hubble nearly a century ago, means that distant galaxies are moving away from us. This is not because they are traveling through space, but because the space between us is increasing. It is a gentle, universal receding, like the surface of a balloon being inflated. Most of what we see in the deep universe follows this pattern. But when we detect peculiar motion, movement that deviates from this expansion, it tells us that there is a source of gravity nearby that is strong enough to resist the stretching of the universe. The detection made by Webb suggests a presence in the void that has its own momentum. It could be a rogue galaxy, a small collection of stars that was ejected from its home cluster by a gravitational slingshot. It could be a massive cloud of dark matter, invisible to our eyes but revealed by the way it bends the light of objects behind it. Or it could be something even more exotic, a dark flow, a current in the cosmic ocean that we are only just beginning to map. In the quiet of the intergalactic medium, even the smallest movement is significant. Because there is so little resistance, an object in motion stays in motion for eons. The detection of such movement is like finding a single footprint on a vast, untouched desert of snow. It tells us that someone or something has passed this way. It tells us that the void is not a dead end, but a transit zone. The James Webb Space Telescope uses its near-infrared camera to peer into these dark stretches. Infrared light is essential for this work because it can pass through the clouds of dust that block visible light. More importantly, as light travels through the expanding universe, its wavelength is stretched, shifting it toward the red and infrared end of the spectrum. This redshift is the tool astronomers use to measure distance and speed. By analyzing the specific tint of the infrared light coming from this moving object, Webb can determine exactly how fast it is traveling and in which direction. The data suggests a trajectory that cuts across the cosmic web. Imagine a vast network of glowing silk threads spanning the universe. Galaxies tend to cluster at the intersections of these threads. The moving object detected by Webb seems to be traveling along one of these filaments, or perhaps leaping from one to another. It is a reminder that the universe has a structure, a skeleton of dark matter that we cannot see, but which provides the pathways for everything we can. As we contemplate the geography of the void, we should feel a sense of peace. The distances are so great that nothing out there can truly threaten us. We are safe in our little corner of the Milky Way. But the knowledge of what lies beyond, of the travelers moving through the dark, enriches our understanding of the whole. It tells us that the story of the universe is still being written, and that there are characters in this story that we are only now meeting for the first time. The something moving outside our galaxy represents the unknown. In the history of science, the unknown has often been a source of fear, but in the context of cosmology, it is a source of wonder. Each new detection is a piece of a puzzle that we have been trying to solve since we first looked at the stars. The void is not a wall, it is a doorway. And as Webb looks through that doorway, it sees a universe that is restless, vibrant, and full of hidden paths. We are learning that the space between galaxies is not a wasteland, it is a reservoir of potential. It contains the gas that will one day fall into galaxies to form new stars. It contains the echoes of the Big Bang. And now we know it contains movement. This movement is a pulse, a heartbeat in the darkness, proving that even in the furthest reaches of the cosmos, the laws of physics are at work, creating a narrative of motion and change. Let us sit with this image for a moment, the great golden eye of Webb staring into the blackness between the stars and seeing the slow, steady progress of a distant wanderer. It is a quiet discovery, but it changes everything. It means our galaxy is not an island, but part of a busy, interconnected archipelago where things move between the shores, and the sea itself is alive with the currents of creation. When we think of a galaxy, we usually imagine a brilliant, swirling firework of light, billions of stars concentrated in a majestic spiral or a glowing elliptical orb. These are the landmarks of the universe, the brightly lit cities that draw our attention. But the movement James Webb has detected belongs to a different class of celestial entity. Scientists often call them ghost galaxies, or more technically, ultra-diffuse galaxies. These are objects that have the mass of a galaxy but almost none of the light. They are spread thin, their stars so far apart that they are nearly transparent. Imagine a cloud of smoke drifting through a dark room. If you shine a bright flashlight through it, the light simply passes through. To the naked eye, it might be invisible. But if you have a camera that can sense the faint heat of the individual particles of smoke, the cloud suddenly appears. This is what Webb is doing. It has found a ghost, a massive, sprawling structure moving through the intergalactic void, barely clinging to the light of its few ancient stars. What makes this discovery so profound is not just that this object exists, but that it is moving in a direction that defies simple explanation. In the grand map of the universe, everything is supposed to follow the general expansion. But this ghostly traveler is moving with a peculiar velocity, a private momentum that suggests it is being summoned. It is as if it is caught in a current, a cosmic river that we cannot see, but which is powerful enough to pull an entire galaxy along its path. This leads us to one of the most hauntingly beautiful concepts in modern cosmology, the idea of dark flow. For years, astronomers have noticed that clusters of galaxies seem to be heading toward a specific point in the distant universe, a region far beyond our current horizon. They are not just drifting, they are surging, like water flowing toward a drain. The detection made by Webb suggests that even the loneliest objects in the deep void are subject to this pull. As we narrate this journey, let us visualize this ghost galaxy. It is a lonely place. If you were standing on a planet inside this moving ghost, the night sky would be terrifyingly black. There would be no dense bands of starlight like our Milky Way. You might see only one or two dim red stars in the entire sky. The nearest neighbor might be millions of light years away. You would feel as though you were at the very edge of existence. And yet, you would be moving. Your entire world, your entire history would be hurtling through the vacuum at hundreds of kilometers per second, drawn toward an invisible destiny. Why are these galaxies so dark? It is a question that Webb is uniquely equipped to answer. Some theories suggest that these ghosts were once normal galaxies that had their gas stripped away by a larger neighbor, leaving behind only a skeleton of stars and a massive heart of dark matter. Others believe they are failed galaxies. Objects that began to form in the early universe but never quite found the rhythm to create the dense stellar nurseries we see in the Milky Way. The detection of this motion tells us something vital about the dark matter that surrounds us. We cannot see dark matter, but we know it is there because of its gravity. It acts as the glue that holds galaxies together and the tracks upon which they travel. This moving ghost detected by Webb is likely a massive clump of dark matter that has captured a few stray stars. By tracking its movement, we are essentially mapping the invisible skeleton of the cosmos. We are seeing the wind by watching how the leaves move. In the gentle silence of the intergalactic medium, this movement is a whisper of the universe's past. These ghost galaxies are relics. They are survivors from a time when the universe was smaller, hotter, and more chaotic. Now, in the cold maturity of the cosmos, they drift like icebergs in a dark sea. Webb's ability to see them, to track their slow, steady progress, gives us a glimpse into the true scale of the cosmic machine. It is a humbling thought. We spend our lives focused on the bright, the loud, and the immediate, but the majority of the universe's story is being told in the dark. It is being told by objects that don't want to be found, moving through spaces we can barely imagine toward goals we have yet to name. The ghost galaxy detected by Webb is a messenger. It tells us that even the void is full of history. It tells us that nothing in the universe is truly still. Even in the deepest, most isolated reaches of space, the dance continues. As we look at the data coming back from the telescope, we see not just a dot on a screen, but a biography of a traveler. We see the path it has taken over billions of years. We see the way it has avoided the hungry maws of larger galaxies. And we see its future, a long, slow drift into the unknown. It is a reminder that we are all travelers, whether we are on a planet, in a star system, or in a ghost galaxy moving through the night. The scale is different, but the journey is the same. To speak of motion in the deep universe is to speak the language of gravity. Gravity is the most patient force in existence. It does not rush. It does not tire. It reaches across millions of light years with a gentle, persistent tug, connecting the smallest atom to the largest supercluster. When James Webb detects something moving outside our galaxy, it is essentially detecting the conversation gravity is having with mass. In our daily lives, we think of gravity as the force that keeps our feet on the ground or makes an apple fall from a tree. But on a cosmic scale, gravity is the architect of everything. It is the force that sculpted the first clouds of hydrogen into stars. It is the force that gathered those stars into galaxies. And it is the force that is currently pulling the detected object through the intergalactic void. How does Webb see this gravity? It does so through the distortion of light and the signature of heat. One of the most remarkable things about the James Webb Space Telescope is its sensitivity to the infrared spectrum. Visible light is only a small part of the story. Much of the universe's activity happens at temperatures just above absolute zero. At these temperatures, objects don't glow with white or blue light. They emit a faint, low-frequency hum of infrared radiation. When Webb points its golden mirrors toward the void, it isn't looking for a flash. It is looking for a glow, a thermal thumbprint. The moving object outside our galaxy has a specific temperature. By measuring that temperature with incredible precision, Webb can determine the object's mass. And once we know the mass, we can understand how it interacts with the gravity of everything around it. There is a concept in physics called gravitational lensing. Because mass curves the fabric of space-time, a massive object acting as a lens can bend the light of things behind it. It is like looking through the bottom of a wine glass. Even if the object itself is dark, like a ghost galaxy or a clump of dark matter. It leaves a visual scar on the background of the universe. Webb is so powerful that it can detect these subtle distortions, allowing us to see the invisible mass that is causing the movement. But there is another layer to this scientific mystery, the expansion of the universe itself. We live in a universe governed by lambda CDM, a model where dark energy, lambda, and cold dark matter, CDM, are the primary actors. Dark energy is the force that is pushing the universe apart, making space grow larger every second. Gravity is the force trying to pull it back together. The movement detected by Webb is happening in the crossfire of these two giants. The object is being pushed away from us by the expansion of space, but it is also being pulled towards something else by gravity. By calculating the difference between these two forces, astronomers can determine the object's true motion. This is a delicate calculation, requiring Webb to observe the object over long periods to see how its position changes relative to the distant, fixed stars of the early universe. Let us think about the heat for a moment. In the absolute cold of the intergalactic medium, even the slightest movement generates a form of energy. As the moving object passes through the thin gas of the intergalactic medium, it creates a bow shock, a gentle wave of compressed gas, much like the wake of a ship in a harbor. This wake is slightly warmer than the surrounding space. Webb's instruments are so sensitive that they can detect this wake, providing a trail that shows us where the object has been and where it is going. This is the beauty of infrared astronomy. It turns the dark, cold vacuum into a map of energy and motion. It allows us to see the invisible strings of gravity that are currently being pulled. When we say James Webb has detected something moving, we are saying it has detected a ripple in the fabric of the cosmos. We must also consider the role of dark matter in this dance. We know that dark matter makes up about 85% of the matter in the universe. It doesn't interact with light, it doesn't emit heat, and it doesn't reflect anything. It is the ultimate shadow. Yet, it is the primary source of gravity. The moving object Webb found is likely embedded in a halo of dark matter. The stars we see are just the passengers. The dark matter is the vehicle. Webb is helping us understand how these dark matter vehicles navigate the cosmic web. The web is not just a metaphor, it is a physical structure. Computer simulations of the universe show a vast, intricate network of filaments. Gravity pulls matter toward these filaments, and it flows along them like cars on a highway. The detection of a moving object outside our galaxy is likely the detection of a traveler on one of these intergalactic highways, heading toward a major intersection, a galaxy cluster. The language of gravity and heat is a quiet one. It doesn't use the loud explosions of supernovae or the violent screams of black holes. It uses the slow, steady logic of physics. It tells us that the universe is a coherent whole where every part is connected to every other part. The movement of a single ghost galaxy millions of light years away is a reflection of the same laws that keep the moon in orbit around the Earth. As we reach the final movement of this cosmic narrative, we find ourselves returning to the silence of the second Lagrange point, where the James Webb Space Telescope continues its lonely vigil. The discovery of something moving outside our galaxy, that ghostly traveler navigating the intergalactic deep, is more than just a data point in a ledger of astronomical events. It is a fundamental shift in how we perceive the emptiness that surrounds our home. We are beginning to realize that the universe does not end at the edges of the Milky Way, nor does the story of life, motion, and complexity. The something Webb has detected is a bridge, a connecting thread that ties our local neighborhood to the grand, unfathomable architecture of the entire cosmos. To understand where this moving object is going, we must consider the ultimate destination of all things in our corner of the universe. Beyond the local void, beyond the immediate neighbors like Andromeda and the Triangulum Galaxy, lies a region of space known as the Great Attractor. It is a gravitational anomaly so massive, so profound, that it is pulling thousands of galaxies, including our own, toward it. The movement Webb has detected is likely a small, quiet part of this much larger surge. It is a single drop of water in a hidden current that flows toward a sea we cannot yet see. This dark flow, this steady migration of matter across the vacuum, suggests that the universe is not just expanding, but is also organized into vast, purposeful streams. Imagine the perspective of a single star within that moving ghost galaxy. To us, it is a speck of infrared heat, but to the star, it is the center of a world. It has been traveling for billions of years, perhaps ejected from a violent cluster in the early universe, now finding its way through the most desolate stretches of space. It moves at hundreds of miles per second, yet because the distances are so vast, it appears nearly stationary. This is the paradox of cosmic motion. It is incredibly fast, yet feels eternal. It is a reminder that our human definitions of time, minutes, hours, years are insufficient for the scale of the heavens. In the time it takes for that object to move the width of a single thumbprint against the sky, entire civilizations on Earth may rise and fall. The James Webb Space Telescope has given us the gift of this perspective. By looking at the something moving outside our galaxy, it forces us to step outside our own small concerns. It reminds us that we are passengers on a craft, the Milky Way, that is itself a traveler. We are not standing still. We are hurtling through the dark at speeds that would shatter our senses if we could feel them. We are part of the same current as the ghost galaxy. We are all heading toward the same distant gravitational horizon. This shared destiny creates a sense of unity that transcends the coldness of the vacuum. We are not alone in the dark because the dark itself is alive with motion. In the quiet of our observations, we must also reflect on the role of the observer. Why do we build these golden eyes? Why do we spend decades and billions of dollars to detect a faint shift in light millions of light years away? We do it because we are the universe's way of knowing itself. The photons that left that moving object eons ago have finally found a home on the mirrors of Webb. They have been translated into electrical signals, beamed back to Earth, and processed by human minds. In that moment, the moving object is no longer just a shadow in the void. It is a thought, a realization, a piece of knowledge. We have brought the furthest reaches of the outside into the inside of our understanding. The detection of motion where we expected stillness is a recurring theme in the history of science. We once thought the Earth was the center of the universe, fixed and immovable. We were wrong. We then thought the Sun was the center. We were wrong again. We thought our galaxy was the entire universe. Again, we were shown a larger truth. Now, as Webb looks into the intergalactic medium, it is showing us that even the voids are not empty, and even the outside is not a wasteland. Every time we think we have found the edge of the map expands. Every time we think we have heard the final note of the symphony, a new movement begins. As we conclude this journey, let us think about the future of that moving traveler. In a few billion years, it may be absorbed into a larger galaxy cluster. Its stars may find new homes, mingling with the light of other suns. Or it may continue its lonely drift into the ever-expanding distance, eventually becoming so far away that even a telescope as powerful as Webb will no longer be able to find it. This is the fate of all things in an expanding universe. Eventually, the light will grow too faint to reach us. The something moving outside our galaxy is a precious glimpse into a reality that is slowly receding from our grasp. It is a reminder to look now, to wonder now, while the windows are still open. The James Webb Space Telescope will continue to stare. Its mirrors will not grow tired, its sensors will not blink. It will continue to map the threads of the cosmic web, tracking the slow, steady progress of the ghosts and the giants that inhabit the dark. And we, here on our small blue planet, will continue to listen. We all find comfort in the knowledge that the universe is a place of constant activity, even in its most remote corners. The silence of the night is not the silence of the void, it is the silence of a deep, focused concentration. Let us return one last time to the image of that detection. A tiny infrared signal, a whisper in the dark, a movement outside our galaxy. It tells us that the story of the cosmos is far grander than our brightest stars. It tells us that the dark is not a wall, but a canvas. And on that canvas, the laws of physics are painting a masterpiece of motion and time. We are lucky to be here to see it. We are lucky to have built a machine that can sense the heartbeat of the universe. As you drift into sleep, or as you sit in the quiet of your own thoughts, remember the traveler. Remember the ghost galaxy moving through the night. It is out there right now, crossing the empty spaces, guided by the invisible hand of gravity. It is a part of you, and you are a part of it. We are all moving together through a universe that is vast, beautiful, and never truly still. The eye that never blinks has seen the truth. The outside is just as alive as the inside, and the journey never truly ends. The lights of the Milky Way are our home, but the movement in the distance is our future. It is the call of the unknown, the lure of the great outside. And as long as we have the courage to look, as long as we have the tools to see, we will never be lost. We will simply be travelers, moving together through the eternal golden glow of a universe that is just beginning to reveal its deepest secrets. Good night to the stars. Good night to the telescope hanging in the shadow. And good night to the something moving far out there in the dark, reminding us that we are all part of the same magnificent motion. The James Webb Space Telescope has seen it, and now so have we. The universe is moving, and it is a beautiful thing to behold.